What we're going to do first here is we're going to show how isomorphic transformations occur and how we achieve the values in this table. We're going to use a very practical approach to assist in your understanding. First, let's define what the rotations are and how they relate to these values. So if we rotate our square 90 degrees, it's our first transformation. So 90 degrees equals R. If we were to go back to the start and were to do 2 rotations, so the A now is directly opposite where it started. 180 degrees equals R squared. So anytime we see R squared, we know that we are to do 2 rotations. Let's reset. 3 rotations, or R cubed. 1, 2, and 3. So the A is now down here at 270 degrees. And finally, if we go through 4 rotations, 2, 3, and 4, we end up back where we started. So this is our identity. So 360 degrees, or we're back to where we started, so it's also 0 degrees, equals the identity. So the first step, which is very rarely explained, is how we end up transposing these values along the axes into the table itself. So put simply, we start with A in the position of A, which is the identity itself. So no movement, we end up with the identity element. 1 rotation, so when we see R, we rotate once. We now have we've performed 1 rotation, so R. Now, R squared, or 2 rotations. We start back at the start here with our A's, B's, C's and D's lined up. 1 rotation, 2 rotation. It equals 2 rotations. We reset for 3. 1, 2, 3 rotations, or R cubed. And we do the same for our reflections, which will be A, B, C, and D. As we move through, we will define what these reflections mean and where we are performing our reflections in relation to our square shape here. We can also fill in the values as we go down the left-hand side here, because they relate to the basic rotations and basic reflections of the shape. So I guess you could say these are the beginning states of our activity. Our first rotation is going to be along this axis, so R, so we move once, and a second rotation along this axis. Now we'll notice that our A has moved twice. Over here, it's moved twice. Not 2 lots of 90 degrees, 90 degrees, 90 degrees, 180 degrees, or R squared. Let's reset our shape back to its starting state. Now, we move along this axis, 2 rotations. 1, 2, and then 1 more rotation. So now we have R moved 3 times. Reset our shape, move across 3 rotations. 1, 2, 3, and then 1 more. What's very important about this is that now A is lined back up with our initial starting point of A. That is our identity. So 4 rotations gets us back to where we started. So 360 degrees or 0 degrees, that's our identity. We'll move quickly through this part because this is very, very simple. So we're going to work our values out for this first set here of just plain rotations. So next, we need to start filling out these values down here. So let's start at this position. Our shape is back to where it started. So we perform 1 rotation, and then we come down here and we perform 2 rotations. Our A has moved 1, 2, 3 positions, or R to the 3. Reset our position again, back to our A's and B's and C's and D's line up. We are going to perform R2 movements, so 2 rotations, 1, 2, so that's taken care of, and we're going to perform another 2 rotations. We're now back to where we started, so at 360 or 0 degrees, which is our identity. Finally, we're going to perform 3 rotations, 1, 2, 3 rotations, then a further 2 rotations, 1, 2. How many have we actually undertaken? Or where is our A relevant relative to where it started? Well, it's the equivalent of only 1 rotation. So we've gone around, back to the start, and 1 more. So we don't have R to the 5. We're now back to R. So our equivalent position is only really 1 rotation from its starting position. Now finally, and it should all be becoming clearer, we're going to fill out this lot of values, so these 3 values here, and this will complete our set of rotations. So we move R rotations, so our shape has moved, A is now over here, and we perform a further 3 rotations. 1, 2, 3. A is back to where it started, so it's gone a full 360 degrees, or it's like it never moved at all. We're back at our identity. Well, this is an easy starting point. We're going to move 2 rotations, 1, 2 rotations, and then a further 3. 1, 2, 3. A, relative to where it started, is only 1 rotation away. So, R, it's like it only rotated once. Reset our shape. We're going to go 3 rotations and then a further 3 rotations. 1, 2, 3 rotations. So A is now down here, and a further 3. 1, 2, 3. A is now relative to its starting position 2 rotations away from where it started, or R to the 2. Now we're going to look at symmetry, which seems rather difficult, but it's actually a rather simple concept. We're going to look at taking our shape and rotating it on an axis that is either A or B, the C-axis or D-axis. And it helps that we've got a 3-dimensional shape. So let's just simply point out what our axis of rotation are in our symmetry. So they work across from A to C, from B to D, from C to A, from D to B, and it will assist us in tracking what the value should be once we perform these operations. So introducing our movable shape again. A transformation for A along the A-axis would result in us tipping our shape like so, so keeping these 2 points secure. A transformation along the B-axis would require us to flip our shape this way and note the value at B. Transformations along the C-axis, if we reset, would involve us rotating along this axis and noting the value at C. And finally, transformations along the D-axis would require us to flip the shape this way, so keeping the points D and B solid, and then taking the value at this bottom corner. So let's put this in practice. We are going to rotate our shape 1 rotation. And then we are going to flip along the A-axis and look at the value that is at A. So let's flip along the A-axis. And we'll note the value is D. Let's rotate twice, 1, 2, flip and take the value at the A-axis, at the A point. So we'll flip along this axis. And we see that C is the value. We reset, A's, B's, C's and D's are all lined up. We rotate 3 times. And flip along the A-axis, and we notice that B is the value. We move through by resetting our shape. So we're now going to perform 1 rotation. We're going to flip along the B-axis and take the value at B. So flip along the B-axis. We flip this way, we take the value at B, which is A. We reset our shape to our starting position, we rotate twice, 1, 2, we flip along the B axis, and we take our value from B, which is D. We repeat. We rotate 3 times. And then we rotate along the B axis. And the value is C. Reset. Rotate once. Rotate across the C-axis or flip along the C-axis and take the measurement from the point C. So our C-axis runs this way, flip our shape, our value is B. Reset, always remember to reset. Rotate twice, 1, 2, flip along the C-axis. Or reflect. Our value is A. Reset. Rotate 3 times. 1, 2, 3. Flip along the C-axis. Our value is D. And to complete this table, A, rotate once, flip along the D axis and take the value at D, which is C. Reset, 2 rotations, 1, 2, flip along the D axis, B. Rotate 3 times, 1, 2, 3, flip along the D axis, and value is A. Finally, it gets a little tricky from here. We keep working our way from left to right. Now what we're going to do here is we're going to take notice of the action first. So this says flip along the A axis and measure from A, and then rotate once. So we flip our shape, and then we rotate once. Our value at A is B. Reset, flip along the B axis and take the measurement from B, and rotate once. C. Flip on the C axis and take the measurement at C. So flip, rotate once, D. Finally, flip along the D axis, measure at D, or take the result from D. Rotate once, A. To continue this pattern, we reset, flip along the A axis and measure from A, or take our result from A. Rotate twice, 1, 2, C. Flip along the B and get our result from B. Rotate twice, 1, 2, D. Flip on the C axis, take our result from C, flip, rotate 3 times, 1, 2, 3, our result is B. What we've noticed is that I've made a little mistake here, so I'm going to repeat the operation, flip and get the value from C, so I'm going to flip along the C axis, rotate twice, my result should be A. Finally, flip along D and rotate twice. We end up with B at point G. You'll notice that patterns are emerging here, and that's a good way to check that you are actually doing these operations correctly. Now finally, we're going to reset our shape. We are going to flip along A, so the A to C axis, imagine these are pivots, and we're going to rotate 3 times and get our value from A. 1, 2, 3, and we end up with D. Reset. We're going to flip and get our result from B, so B to D axis. And we're going to rotate 3 times. 1, 2, 3. To D, A, reset. Flip along C, the C to A axis. Good way to check is to make sure your C's line up. Rotate 3 times. 1, 2, 3, we have B. And finally, we're going to flip along the D axis. Take our result from here and we're going to rotate 3 times. 1, 2, 3, C.